last unit. Okay? So last unit we discussed rigid motion. So transformations that don't change the size or shape of a figure, just changes its location. So a translation, that was a rigid motion because it just slid the figure around the coordinate plane. A rotation was a rigid motion because it just turned a figure around the coordinate plane. A reflection was a rigid motion because it just flipped a figure about the coordinate plane. Okay? This unit, we're going to talk about a new type of transformation, which is called a dilation. A dilation changes the size of a figure, so it makes it larger or smaller, but not its shape. Just changing its size. So based off that definition, true or false, a dilation is a rigid motion. False. Dilations change the size of a figure. Therefore, it is not a rigid motion. Rigid motions create figures that are congruent, meaning all the corresponding sides and angles are the same. Also meaning that the pre-image and image are always congruent to each other. So whenever you do a translation, a reflection, or a rotation, the original figure is always congruent to the new figure. Okay? So knowing this, a translation was done below, which again is rigid motion. State what we know about the corresponding angles and sides. Well, we know they're the same. Okay? We didn't change the size of the figure, we just split it. So we know all the corresponding angles are the same. So angle G, what is angle G's corresponding angle? G prime. So angle G and angle G prime are the same. Okay. Angle B, what is angle B's corresponding angle? B prime. So angle B and angle B prime are the same. Same measure. Okay. And what is angle T's corresponding angle? T prime. So angle T and angle T prime, they're the same. Same measure. Wherever they are, they're the same. We also know that their corresponding sides are the same. Okay. So I know that side GB is congruent to its corresponding side G prime B prime. If we count, GB's 1, 2, 3, 4. 1, 2, 3, 4. They're the same. I also know that side GT is congruent to G prime T prime. Again, if you count, they both have a length of 2. And then I know BT is congruent to its corresponding side B prime T prime. Nothing changed when we did the translation. Everything stayed the same. We just changed its location on the grid. Questions over that? Well, when we do a dilation, dilations create similar figures. Okay? Similar figures have corresponding angles that are congruent. So their angles are still going to be the same. After you do a dilation, angle measurement is still preserved. You didn't change how wide the figure is. You changed how big or how small it is. Okay? But because you did change the sides, they're not the same. They're what we call proportional. So when you do a dilation, you're creating a similar figure. For a figure to be similar, their angles are, the corresponding angles are congruent, and the sides are proportional. Proportional means that the ratio, that's what a proportion is, it's ratios, of the corresponding sides are the same. Meaning if you take the length of the corresponding sides and turn them into fractions, all the fractions will be the same. When performing a dilation, the pre-image and image are always similar to each other. So here we did a dilation. We're going to write what we know about the angles and the sides. When we do a dilation, do the angles change? No, the angles stay the same. to be congruent to its corresponding angle, which is what? A prime.
A prime.
A prime. So that means angle P is congruent to its corresponding angle, which is P prime. Angle L is still going to be congruent to L prime, and J is still going to be congruent to J prime. The angles do not change when you do a dilation. The angle measurements are still the same. That doesn't change. What changes is the length of the side. And when you do a dilation, you're creating sides that are proportional, meaning, and the order right now doesn't matter. It matters here in a couple of lessons, but right now it doesn't matter. That means we take whatever AP is and put it over the length of A prime P prime. Okay. That fraction is going to be same if we do that for all the other sides. So that fraction is going to be the same as if we did AJ over A prime J prime. Those two fractions are the same. That is also going to be the same when we do JL over J prime L prime. That length will be that fraction will be the same. That's also going to be the same as PL over P prime L prime. If you are a more numbers person, if you notice, PL is 2. The length of P prime L prime is a half, I would say, 0.5. And 2 divided by 0.5 is that 4? 2 divided by 0.5, what do we get? We get 4. Yes, no, maybe so? No, we calculator. Four. That means, thank you for that verification. So the length of PL is 2, the length of P prime L prime is 0.5. So that fraction reduces down to 4. If we wanted to do the math, we're not going to do it, but if we found the distance of all 4 sides of the original and all the other slanted sides of the new and made them into fractions, all these fractions are equal to 4. That's what that means. Okay? Question. So this equals 4. This would simplify down to 4. That would simplify down to 4. And that would simplify down to 4. They'd all equal 4. That's what it means to be proportional. Questions over there? The ratio of the sides of similar figures is called the scale factor. We use the scale factor to enlarge or reduce the size of a figure when performing a dilation. When the scale factor is less than 1, the figure will become smaller, which we call a reduction. When the scale factor is greater than 1, the figure will become larger, which is an enlargement. When asked to transform a figure by dilation, it will sometimes be written in sentence form. It will just say, dilate this figure by a scale factor of 4. It will say something like that. Or it's going to be written in this algebraic notation. Okay? Okay. What happens is, that really looks similar to how a translation is written. You have to know the difference between a dilation and a translation. A dilation, if you notice, there's no addition marks. The numbers just right in front of the x and the numbers right in front of the y. A translation would look something like this. There'll be plus signs or minus signs in between. So a translation might look like x plus 4, y plus 4. This is a translation. The green's a translation. That means a dilation. Okay? Know the difference. Sometimes we see translations written like that, and we end up doing a dilation or vice versa. Okay? So know the difference. With scale factor, when it's written in this algebraic form, it's just the number that's in front of the x and the y. Okay? When you perform a dilation, all you're doing is just multiplying the x and y values by the scale factor. Okay, so you're multiplying all the x values by 4. In that example, you're multiplying all the y values by 4. Questions over that? So let's do an example. We're going to write the coordinates of the image of a figure with these vertices after we do the following transformation. There's no plus or minus signs. There's just a number in front of the x and the y that's telling me I'm doing a dilation. What did we just say? What do we do? What is this rule telling us to do? What are we going to do with all our x and y values in our scale factor? We're going to multiply them. So we're just going to multiply all these numbers by the scale factor, which is 1/3. So to get a prime, I'm going to multiply a by 1/3. What's negative 9 times 1/3? What is 6 times 1/3? So a prime, the image would be at negative 3, 2. What about b? B prime. What's negative 1 times 1/3 as a fraction? And what is 3 times 1/3? 1. What do we get for C? What do we get when we do 12 times 1/3?
4.
4. And what's 0 times anything? And then, all my numbers, right? And then D prime. What's 3 times 1/3? 1. And negative 15 times 1/3? Yep. That's all you do when you do annihilation. This one, they didn't need you to graph it. They just wanted you to write down the coordinates. So sometimes they just ask what are the new coordinates, and you just write them down. You don't actually have to graph. Questions over that? If we take a look at example 1, we want to graph image of the following figure after the given transformation. What transformation is it telling us to do? When it's written like this. A dilation. Okay? So when we do a dilation, Ryan, you mentioned it, what are we doing with all our vertices? Multiply them by 2. Well, to do that, or what I like to do, is I write down my original vertices. My original F is located where? What are the coordinates of F? Negative 2, 0. What are my coordinates of V? 2, 2. What are my coordinates of, down a little bit, of P? Nope, wrong color. Negative 1, negative 1. And then we're going to do the dilation, so we're going to multiply all these values by 2. Okay. So F prime, when I multiply F by 2, what do we get? Times by 2, we get negative 4. What? 0. Multiply this point by 2. V prime is going to be located where?
-2, -2. Oh, wait, no, sorry.
4, 4. Multiply this one by 2. P prime is going to be at? -2, -2. Multiply x values by 2 and the y values. And then plot your points. So I have negative 4, 0. I have 4, 4. And then negative 2, negative 2. And connect. Okay. F prime, B prime, and P prime. So as you can see, our scale factor was bigger than 1, and our figure got larger. Now let's see, does the slope of the pre-image and image change? So let's find the slope of our pre-image, the original figure. Let's find the slope of each side. So let's find the slope of FV. All we have to do is rise over run. What's our rise? 2. We went up 2. What's our run? 4. What does 2 over 4 simplify down to? 1/2. So the slope of that side is 1/2. Let's find the slope of FP. Well, I went down 1, so it's going to be, let's go this side, negative. And then we went right 1, so that's positive. And what does negative 1 over 1 simplify down to? Negative 1. When we find the slope of PV, I went up 1, 2, 3. How far right do we go? 3. And what does 3 over 3 simplify down to? 1. So that's the slope of all the sides of the original figure. So now we're going to find the slope of our image, our answer. So let's find the slope of F prime, V prime. Well, I went up. How far up did we go? 4. How far over did we go? 8. What does 4 over 8 simplify down to? 1/2. Let's find the slope of F prime, P prime. I went down how far?
2.
I went right how far? 2. So it's negative 2 over 2. What does that simplify down to? Negative 1. Any guesses on what the slope of P prime, V prime is? 1, yeah. Where is it? Okay. We went up 1, 2, 3, 4, 5, 6. And we go right 1, 2, 3, 4, 5, 6. What does 6 over 6 simplify down to? 1. Okay. This is true for all dilations. Okay, when you do a dilation, and I'm sorry, we forgot, we mentioned it, but did the slope change? No, the slope did not change. Slope stayed the same. Okay? So that being said, this is true for all dilations. The slope of the pre-image and image will always be the same. Unless you do a rotation or a reflection, then that will change the slope. But if you just do a dilation, okay, the slopes will be the same of the corresponding sides. This means the corresponding sides of the pre-image and image will also be what? What do we know about lines that have the same slope?
Parallel.
They're parallel. So the corresponding sides, when you just do a dilation, you don't do a rotation or a reflection, the corresponding sides will be parallel to each other. So F prime, P prime, parallel to FP. V prime, F prime, parallel to VF. V prime, P prime, and VP, they're technically the same line. This is a special case because the y-intercept is the origin. So because of that, it doesn't move. That's a long story. Not something usually we need to get into too, but just know when you do a dilation, corresponding sides will be parallel to each other as long as you don't do a reflection or a rotation. Questions on that? That being said, now that we know when we do a dilation, lines are parallel, we're going to write the equation of a line y equals 6x minus 8 after it's been dilated by a scale factor of 1/2. Okay? Well, when we're writing our new equation for this type of problem, when we're dilating lines, we're going to keep it in y equals mx plus b form. We're not given a point, so we can't really use point slope form. So we're just going to keep it in y equals mx plus b form. class. We just said when we do a dilation, the original and the new are what? They're the same. The slopes are the same, which means they're parallel. So what is the slope of my original line?
6.
6. My slope of my original line is 6. What's the slope of my new line then going to be? 6. So whatever the slope of your original line is, that's the slope of your new line. Slope doesn't change when you do a dilation. But all the points on that line do change. All the points that are on that line get multiplied by the scale factor. So the b, which is -8, that's our y-intercept. Okay? That's going to get multiplied by the scale factor. So to get the b of your new line, you just take the b of the original and multiply it by the scale factor. And when we do that, what's -8 times 1/2?
4.
-4. So that's the b of your new line. So when you dilate lines, and you need to write the equation of a line after you've been dilated, whatever the slope is of the original is the slope of your new. Slope stays the same. You just take whatever the b is, multiply it by the scale factor, and that's the b of your new line. And that's your answer. Okay? Questions over that? One more. We take a look at this one. We want to write the slope and the y-intercept. So we don't need to know the equation. We just need to know the two parts. Of a line, 9x plus 3y equals 5 after it is dilated by a scale factor of 6. Well, what's the problem here? It's not in y equals. We have to get it to look like that. What's our first step to get this to be in y equals? Subtract the 9x. So I get 3y is equal to -9x plus 5. Then what do we need to do? Divide by 3. When we do that, we get y is equal to, what's -9 divided by 3? -3. And then does 5/3 simplify or divide evenly, or you get a nice clean decimal when you divide? No, you get like 2.6 repeating, right?
Yeah.
So when that happens, leave it as a fraction. Just leave it like that. So that is the equation of our original line in y equals mx plus b form. We just want to know the slope and the y-intercept of our new line after we dilate it. Well, what do we know about the slopes? They're the same. So what's the slope of our original line? So what's the slope of our new line going to be? -3. What do we have to do with our b to get the y-intercept of our new? Yeah, times it by the scale factor. So we're going to take 5/3 and times it by my scale factor. What do we get when we do 5/3 times 6? So the y-intercept of our new. So you're dilating a line, keep the slope the same, multiply the b by the line, by the scale factor. And that will give you the b of the new. Okay? What you can do, let's say you're nervous to solve for y. In this case, I think it was easier to solve for y, but let's say you don't want to solve for y. What could you do? Nope. Put it into Desmos. Solving for x is you're doing something different. Plug it into Desmos. So you can just plug it in how it is. 9x plus 3y equals 5. Okay? And then you can just find the slope by doing rise over run. Here's the thing. If you rise over run, you need a nice corner point. Do you see a nice corner point anywhere on here? This was an OST question, so I'm going over this with you from like last year or year before. Do you see any nice corner points? I don't see any nice corner points. That's not a nice corner point right here. It's not quite through the corner. So when that happens, and there's no nice corner points, just go from the x-intercept to the y-intercept. That will still give you your rise over your run. Okay? So if you click on your x-intercept and your y-intercept, I'm going from 0 up to my y-intercept, which is 1.667. Well, that's my rise. Right? I went from 0 to 1.667. That means I went up 1.667. My run, if we take a look at, let me click it. My run, I went up 1.667. My run is going from 0.556 to 0, and I went left. So that means I went negative 0.556. If you divide that in decimals, if we do 1.667 divided by negative negative 0.556, that's roughly what? If you'd around that, that's about what? Negative 3, right? That was the slope when we solved. To get your new y-intercept, you just click it on the graph. Well, my y-intercept is 1.667, and I multiply it by the scale factor, which is 6, and that's roughly what? So this is an instance where it's a little bit harder to use decimals. Sometimes not everything comes out nice, neat, and pretty and simple, but you can still do the rise over the run and still get your y-intercept. You just have to think about it around a little bit. Okay. Questions? Okay. Rest of the time is yours. Work on that practice.